Everyone, this is Don Ferguson with the Appalachian Search and Rescue Conference, and I'm here with another video tutorial on using Integrated Geospatial Tools for Search and Rescue, or Igt4Sar. In today's video, I want to talk about the Minimum Essential Data Set, or the MED. And what we're talking about here is the minimum spatial data sets, other than the incident data that you create on scene, that you'd use in a GIS to effectively meet the needs of responding to a SAR incident. And this is data beyond the base data, or beyond the base map. And what I want to focus here on is basically the concept of MED, and not so much on where you may get the MEDs or what data you want to incorporate in there, but I want to talk about sort of the concept and the benefits of having additional data beyond just the base map. If you're looking for some more detailed information on the types of data that you may want to include into your MED package, a great resource is George Durkee and Vanessa Glenn Linares' text on using GIS for wildland search and rescue. This is a free download from the URL that's listed here, and they have a whole chapter dedicated to pre-planning and to MED development. So that they talk about the types of data that you may want to include. I'm going to focus on sort of the basic concepts, why you want to have additional data beyond a base map, and I'm also want to talk about how you can use some of that additional data to benefit you by allowing you to do different types of analyses or different types of functions within a GIS. So this is a great reference for telling you the types of data that you may want to incorporate. Actually, another good reference for explaining the types of data or detailing the types of data that you may want to incorporate into your map package is the table of contents of Igt4Sar. So in the table of contents, there's an analysis group and a base data group, and in there are data groups that encourage you or suggest to you the types of data that you may want to include into your package here. So you may want to include roads, trails, hydrology, lake streams, and water polygons, cell towers, things like that. And you want to include those things because it allows you to do different types of analyses, or it helps you to do certain things with tasking and creating search areas. The other thing that the primary thing that incorporating additional spatial data onto your base map does is improves your situational awareness. You need to improve your situational awareness to make it safer and more effective for your searchers, as well as to have a better understanding of the environment that your subject is in. The better you understand the environment, the more likely you'll find the subject. Quicker, at least, or at least it'll help you understand the decisions that the subject would have been faced with. The other thing that your minimum essential data set is going to do for you is it's also going to give you attribute information about the different features. So these spatial data that you see on the map are not just graphical representations of different features, but there's also information in that feature. There's attributes that tell you, when the road was last maintained, or what types of material the road is made out of, whether it be blacktop or gravel, or what's the maintenance level for a particular trail, or it may tell you who the owner of a particular gate is that's locked. If the gate's represented as a point on the map, it'll tell you an elevation value. Lots of different types of attributes are incorporated in there. The other thing about these additional features is that they're interactive. We're now in a digital environment. We can actually interact with the data to be able to do different types of analyses or create new features. And I will talk a little bit later about where you can get some from national repositories, or you can get data that's relevant to your local area as well. So historically, we've used topographical maps, these big paper maps, and if there have been features that weren't on the map that we felt should have been there, we would draw them in manually. And that works okay on one or two maps, but if you have a lot of maps that you need to get out there and you're drawing these features on every map, sooner or later you're going to forget to draw a feature, or the shift's going to change and people are going to forget that feature was even there. So So with the GIS, we can incorporate that feature into our actual map and allow us to turn layers on and off. Now we can argue that topographical maps are sufficient for conducting search operations because that's what we've always used. We've either used maybe a topographical map or a park map or something like that. And yes, we have found people by doing that. However, there are now, again, being in a digital environment, a digital age, there are now tools that can make this process easier to deal with and improve your situational awareness. That is the key thing here: is improving your situational awareness. Um, and and that's what we're going to do with this data. The topographical maps are typically outdated, and even the aerial images don't give us a lot of detail about what is actually on the ground. We can't see through the leaves on an aerial image, or we can't actually understand the exact shape of the trail, and all those things are relevant for a search operation in terms of improving searcher safety and their effectiveness, as well as understanding the decisions that the subject have to make. So we need to have accurate data in order to effectively manage a search operation. So what kind of data do we need? Again, I don't want to look at this in grave detail and talk about each different types of data, but conceptually, the types of data that we need are going to be driven by the types of functions that we perform. So in a search operation, we need to get teams out in the field, and we want them to function safely and effectively. So we need to think about the types of data that they're going to need in order to be able to accomplish those goals of being safe and effective. So they need to have trails, they need to know points of interest that are out there, they need to know where hazards are, they need to know what the terrain looks like, they need to know if there's a difference between what they see on the topographical map and what is actually out there in the real world. So you need to think about the types of data that they're going to need in order to accomplish a function of being able to safely and effectively search out into the field. The other thing that one of the other functions is the planning phase, and how do we think about what the subject must have encountered in the environment, and in order to do that accurately, we need to have up-to-date spatial data incorporated into our map, and that'll lead us to understand the decisions they would make, that the subject had to make. That'll also allow us to use different types of analytical tools that are built into Igt4Sar and ArcGIS, and things like that. And then another function that we do is we need to be able to tell other people what's going on. We need to be able to brief responsible authorities or the press or the family members or the general public. We may need things like jurisdictional boundaries to say that who's in charge of this search operation, and what happens as we cross jurisdictional lines. Or administrative boundaries and things like that. So those are our primary functions that we need to keep in mind as we think about the types of data that we're gonna need. Now, in order to help this process, what I've done is developed a table, and I've sort of adapted this table from one that was very similar to this that's published in the Wildland Fire arena. And what I've done is define different types of products that you may develop, from an incident action planning map to a field team map to a briefing map, and the types of data that you may want to incorporate into those maps. O's means optional, R's means that the data is required, and even that is, I'd say, up for debate, because you can decide what is required for your area, or for the map that you're making. So this is really just some suggestions on the types of data that you may want to incorporate into your different products that you're producing and utilizing during a search operation. So the two types of data sets that we're going to be working with are raster data and vector data. And raster data is where an attribute is associated with a cell. So this is what you think of this as a picture you would take with a digital camera. And everybody talks about the megapixels of the camera, and the reason you want more megapixels is basically that means there are more cells to make the picture look clearer. And the same is for raster, but in raster cases, each of those cells provide some information in terms of so rasters are basically images that have been georeferenced. They may be a topographical map, they may be an aerial image, a street map, or it could be a digital elevation model, or a land cover, or even a georeferenced image of, say, an existing map. But all those raster data sets, or all that raster data, the cell has got relevant information. In the case of a topographical map, the cell tells it how to, what the picture looks like. But in terms of a digital elevation, the cell would give you the elevation at that point. So with the raster data are associated with the cell. The other type of data, the vector data, and this is where you have, these are the actual points, lines, and areas or polygons that make up a feature on the map. In the raster data, you see those points, lines, and polygons, but they are really just graphical or visual representations of the actual points, lines, and polygons. With vector data, it is the actual points, lines, and polygons, and you can with the vector data, you can associate lots of attributes with that data. So with this line that represents a road, you can probe that and get the name of the road, the length of it, maybe the who maintains that road, and things like that. You can actually get access to the attribute data that's associated with the vectors, and we'll talk about that a little bit later on. So let me give you a quick example of why MEDS would be relevant and why it's important from just a situational awareness standpoint. So here's a topographical map, and we're going to focus on this area that I have highlighted here with an arrow. This is a topographical map from 1957. So if we were going to do a search in this area, this is what we'd have. This is what we may have in order to make our decisions. Well, this map has been updated, and the latest topographical map of that area is 1994. And between these two, you can see some significant differences in the map. Where this highway has been added since 1954. However, again, keeping this area in mind, because this is where our search is, if we look at even a more up-to-date aerial image of the area, you can see that area is now a shopping area. So if we were conducting a search in that area, the way we conduct a search in a shopping area versus an open field would be considerably different. So by improving our situational awareness, we can make the right choices and be able to search an area appropriately. However, with the appropriate spatial data, we can actually take that 1954 map and update it with 2010 information. So now we've incorporated vector data onto our raster image and have updated it to the 2010 level. And the added benefit of this is now we can interrogate these different features to understand different additional information just beyond what it looks like and where it may be. We can actually get additional attributes from that. So let's go ahead and switch over to ArcGIS and Igt4Sar and take a closer look at how we're going to use some of this additional spatial data. So historically, this is what it would look like when we were running a search operation. We'd have a topographical map, we'd have our initial planning point on here, and this is what we would use to base all our decisions on, and we make copies of this, and so on. But again, we have to ask ourselves: is this the most up-to-date map we have, or the most up-to-date information that we have? Now, we know, if you're familiar with this area, and this is the Sky Meadow State Park in Virginia, if you're familiar with this area, you know by looking at this topographical map, there are a lot of trails that are not shown on this map that are actually there. And we know that by looking at a trail map of this park, and we can see a lot of these additional trails. So what would be great is if we could incorporate this map with the topographical map, to be able to get, because with this map here, we can't probe this map and get coordinates off of this map, for example, and that would be really useful if we were sending teams out in the field and they needed to report back with some information. So So how do we get, how do we improve our situational awareness here? Well, one of the things that we can do is look at or utilize an aerial image of this area. And if we do that, this is what we would see, and we can even zoom in and get closer images of, or a closer look at what we're dealing with here. But again, this is just a picture of the area, and I should say it's a picture with that's been georeferenced, so we can get coordinates from different locations on here, which is nice. But it doesn't really, we can't look at this image and know what the name of this trail is, or the name of this road or anything like that. So something that we can do to improve our situational awareness is to georeference our park map. And if we georeference our park map, we can actually then overlay it on here, and now we have all the trails in the right place. We can get coordinates off of this. We can even print this or incorporate this on to a map that we're going to send out into the field for field teams to use. So that's one way of getting the trails on there, but this is just a graphical representation of the trails. We can't really do anything with them at this point. These are all raster data, and these are additional raster data, and it's very useful raster, and it's something in addition that you can have, but we still can't utilize the different features for different functions. We need to actually get to the vector data to be able to do that. But before we do that, I want to show you another um, type of raster data that you may want to incorporate, and that's the digital elevation model. And what I've done with that, the digital elevation model is created a hillshade using the digital elevation model that you can download. And this is what the hillshade the hillshade looks like. And what it can actually do is it can actually help highlight features. So you can overlay the topographical map with the hillshade and see a lot of different features that way. All right, so now if we want to incorporate some of the vector data into this, we can begin turning on some of the vector data that we have here, and now what we can do is we can actually interrogate some of these features to be able to get additional information about that feature. So now I can click on this feature. I get that that's the South Ridge Trail. It's 1.6 miles, and its maintenance level is 5, which means it's a well-maintained. It's a well-maintained trail. Or one of the other features out here, we see that this is the Appalachian Trail. So the Appalachian Trail is near our search area, so you may want to know, okay, well, or maybe there is a shelter nearby for the Appalachian Trail, and you can download that data from different places out on the internet, the Appalachian Trail shelters, and now you have a point on your map that shows where an Appalachian Trail shelter is, and you know the name of that shelter. Some notes on it where the privy is in relationship to the shelter. It's an official shelter, the source, and things like that. And knowing where that shelter is, and maybe an indication of a location that you'd want to check in looking for your lost subject. So these points of interest are relevant for managing your search operation. So one of the things that we can do is use these features, these vector features, to quickly create hasty lines or hasty segments or search segments or regions if we wanted to. To do that, if we edit, say, our hasty line feature, click on, first find out the name of this. So the name of this is the Northridge Trail. So we want to then select that, copy that, and then paste it into hasty lines. And then we'll call this the North Ridge Trail, and we've just created a hasty line task that then we could create an additional assignment for. If we wanted to create, say, a hasty segment task, we can click on a feature, go up to the editor drop-down menu, and say buffer, buffer it into hasty segment trails, and I'll give it an extra wide distance so you can see it, so 50-meter buffer, and I'm not sure that trail name, but we'll call it the trail, and we can quickly create a buffer for that that could then again be assigned to a team to go out into the field. So that's some examples of how you can use it for quickly doing your search assignments. Some other things that you can do with it are some analyses. So, for example, one of the things that you can do is the track offset. Well, if you have all these features, you can run the track offset tool, and let me hide some of these other things. You can run the track offset tool, and it looks at lost person behavior statistics and generates the how far off the trail subjects have historically been found in for that subject category. Or you could use a variety of data, both vector data and raster data, to create a mobility model for how far the subject could have gone in a certain amount of time. And here's an example of what the mobility model would look like, where each of these different colors is a different amount of time that's passed. So the subject could have followed a trail. And you can see that, with the trails, they can go a little bit further than they could out here in the vegetation. So this uses this particular tool uses streams, trails, roads, power lines, as well as raster data like land cover and the digital elevation model to get slope, to be able to calculate how far somebody could have traveled in a given amount of time. The other thing that we can do with some of this vector data is say some cell phone analysis, and let's say, with the cell phone tower information that we get from the FCC, one of the things that we get if we interrogate a cell tower, let me turn those points back on, they're not already on. So if we interrogate a cell tower and get information on that cell tower, then some of the stuff that we get is the height of that tower. So we know how tall that tower is, and we can use that. We can use the height of that tower to help us with our communications models. So we end up looking at the types of areas that particular tower could cover, and how that relates to where our subject is. So there's lots of different types of analyses that you can do when you have data sets, these vector data sets as well as raster data sets, beyond just a topographical map. So yes, you can do a lot with just a topographical map, but once you have actual features, you can do a whole lot more, and you get all the attribute information that comes along with those features. So where can you get some of this data? I'll quickly cover just a little bit of that before I wrap up. But as I mentioned earlier, you can get base maps directly in ArcGIS or ArcGIS Online. We'll give you access to lots of different base maps there. The National Map Program, you can download topographical maps, you can get raster data for digital elevation models and land cover and things like that. Get GeoPDFs, which you can convert to image files in a couple of different applications, but you can get that from the USGS Map Store. I would highly recommend that you as a SAR professional or volunteer or whatever you may be, that you hook up with your county or state official GIS technicians or individuals, personnel that work on GIS at those levels, or folks that maintain repositories of data at maybe universities or something like that, and you can access lots of different types of data from those places. U.S. Forest Service has got a big pool of data, both vector and raster data that you can access from there, such as raster images of the forest visitor maps that have all been georeferenced, and then lots of other repositories. The Tiger data is a great data source for line data like roads and hydrology and things like that. I didn't mention, and I'll cover this in another video at some other time, but you can use the digital elevation model to calculate the hydrology as well as sort of the size of the streams from different tool sets within ArcGIS. So with that, I'll go ahead and end the video, and hopefully you guys can have an understanding now of the importance of additional data beyond the base map and how you can utilize that to effectively manage a search operation. So thanks for listening, and stay tuned for the next video that'll be coming soon. Thanks a lot. Bye.